Okay, let us start now. In the last class, I ended my discussion with the effect of energy, effect of coastline energy flux, and then I have discussed that whether what is called actually the your base level and the sea level. Then how we actually talk about the based on the energy, how we talk about the accommodation, which is positive accommodation and the negative accommodation. We ended our discussion with that, if I am not wrong, isn't it?
Yes, sir.
Yeah. So what actually we are getting now, this diagram I possibly have drawn earlier also, but today I will be discussing because I will be again going to the same diagram, so I am drawing it and taking it to the further forward, that how I will take it forward. So this diagram, if you remember, I did it earlier also. Anyway. So what you are basically getting, there are three controls that I have discussed: tectonics, then Eustacy, and then I talked about the climate. That is the energy flux and all these things. Now, this can lead to any tectonic subsidence can cause a global rise or the local rise of the base level. So it can also lead to a Eustacy. Tectonics independently also is also equally important because of the hinterland tectonics which supply the sediment. But when I think about the basin scale, not thinking about the sediments that is being supplied, then I talk about the basinal subsidence and the basinal tectonics. So tectonics, when I talk, there are two different aspects of tectonics. One aspect is the tectonic, that is the hinterland tectonics, which basically is responsible for the sediment supply. Another tectonics, which is responsible for the basinal subsidence or basinal uplift that change the accommodation. So both the tectonics you should not mix. You should not mix both the tectonics. Both the tectonics, their role are different. Okay. Then you have climate. So climate can also can cause a rise because of glaciation, the deglaciation, the climate that can also cause a and these two, the tectonics can also affect the climate. Tectonics can also affect the climate because if you have a tectonics and then you have a rise of a mountain chain, then the weathering, and the weathering, it can consume the all the weathering reaction is the carbon dioxide consuming reaction, and that by that carbon dioxide consuming reaction, you can have a more of a ice house condition. So that tectonics and climate, they are also interrelated to one another. So this is how all the three things, they are interrelated to one another. Okay. Now these are basically all allogenic control. These are all allogenic control. Now, this allogenic control, so all these, that basically what it leads to, it leads to this leads to a accommodation within this accommodation. You have the energy flux. That accommodation which will be generated by their control, that will be worked upon by the energy flux that is available in the basin itself. Suppose wave, the current, they are further creating or increasing or decreasing the accommodation which I discussed in the last class at the end. So one, the accommodation that is also worked upon by the energy flux and the sediment dispersion. sediment dispersion. It is okay. It is okay. And then you have the sediment supply. This is the common normal sediment supply into the basin. So what are the two things I am talking about? This is the accommodation, the energy in the environment of accommodation that is causing again further increase positive or negative of the accommodation, and that wave energy that is causing the sediment to be dispersed. Now this is a sediment supply into the basin. So this sediment supply will directly act on that, and these two together they will cause the final sedimentation in the basin. Final sedimentation in the basin. Is it clear or anything which is not very clear? How this whole thing they are interrelated to one another?
Yes, sir.
If there is any question, you can ask me. These are three aspects which are basically causing the allogenic control, creating the accommodation, which is further worked upon by the energy flux and sediment dispersal, and there is a sediment supply which is filling this accommodation, and that is basically causing the final accommodation. Final accommodation. Final sediment. Now, we will come into this. Now I have already also discussed that what we really talked about a basin. What I really talked about a basin, the definition. You might be remembering this diagram as well, which I earlier drawn in a simplistic way. Today I am discussing it in a more detailed way. This is provenance, and this is how the entire. Suppose think about the entire right from the Himalaya to the Bay of Bengal, which I discussed. The Himalaya is the major prominence, and from that I have created a basin. The basin has a subaqueous part, a subaerial part. Now in the subaqueous part you have the sea or the lake level, which is basically the controlling factor. Now this factor, which is operating in the subaqueous part, it can also be affecting the sedimentation process up to this part. So up to this part, so this is the subaqueous accommodation, this is the subaerial accommodation. Now in the subaqueous accommodation, you are essentially getting the marine strata. Marine strata. What you are getting in the subaerial accommodation, you are getting the fluvial, the aeolian, the lacustrine strata. So what I will be getting here, I am getting the marine strata. What the accommodation I am getting here, I will be getting fluvial, aeolian, lacustrine. All these sediments I am getting in this subaerial part. Now within this subaerial part, again I am dividing it into the upstream and downstream part. From this sea level, what we also refer to as the base level, I will come to it later in a detail. The base level, you have 10 to 100 kilometers upstream of the base level, that actually we call it the downstream of the subaerial part. Okay, where the base level still controls the sedimentation pattern. So in this part also, the base level control sedimentation pattern. So here what I will get the interaction between the continental and marine. Where there it is mostly restricted within the marine strata. Here I will be getting the interaction between the continental and the marine. But the main control will always be the base level. Main control will always be the base level. Now, what will be the control upstream of that, which is essentially the fluvial? There, what will be the control? We will be discussing separately in detail that how the climate and the water table, that is the major control in the further upstream part, which will come in the fluvial sequence stratigraphy. Okay, so there are different parts and they basically respond to the different agency. So I think it is clear to you that how the different accommodation and different environmental condition that is guided in the different part of the section. Is it clear?
Yes, sir.
Okay. So now we will see that in these three different parts, so what I have seen that one is that the marine part, one is the downstream, which is affected by base level, and one is upstream, not affected by base level. Not affected by base level. Not affected by base level. Okay? So in a very simplistic term, when we see that how really the different factors that will be affecting in the different part. So we get the viscosity, tectonics, right? These are so. So in a very simplistic term, if I talk about, then what I find that the Eustachian tectonics and climate, it affects both the fluvial or the non-marine accommodation as well as marine accommodation. Both non-marine and marine accommodation. In case of non-marine, what we also call the fluvial accommodation, non-marine, the climate that basically indicates the fluvial discharge, the sediment volume that the fluvial system will be receiving, the sediment volume. Because the climate, it basically, the humid climate, you will have the higher discharge, the higher sediment supply. The tectonics, it is the tilt or the gradient that you generate by it. And Eustachian, in case of fluvial, it is not really the Eustachian in the upstream part that is affecting, it is the gradient of the surface that is affecting, and that causes the fluvial formation. I will come to the more detail. In case of marine, the wave current, they form the local climatic condition, the energy flux that basically control the tilt and the sea level that basically control the marine accommodation. So when we talk about the three different that I have talked about, the marine system, the downstream affected by base level, upstream not affected by base level, that how the different controls they affect in the different part of the sedimentary basin, the subaerial part and the subaqueous part, and how these three parts they correspond to different. This is in case of marine. This is in case of marine. And what you are basically getting is that you are there are tectonic eustacy that is controlling the sea level, then energy flux that basically is controlling the base level, and that is basically controlling the accommodation, then the sedimentation, which finally they are balanced, that the accommodation generation and the sediment generation, these two balance, the rate of accommodation generation, rate of sedimentation, these two balance, that causes the translation and relocation. This is the basically when we are talking about the marine strata and its control. Marine strata and its control. Now this is for the downstream which is affected by base level, which is affected by base level. So there, what will be controlling it? Controlling the pluvial graded profile. What is pluvial graded profile? A graded profile of a pluvial is that which is actually a profile of a pluvial system which is in equilibrium. Which is in equilibrium. That means a concave up profile of a pluvial system which can neither allow any deposition or any erosion. So when a pluvial system which generates a concave up system which is in equilibrium, not allowing any erosion or deposition, only allowing the sediment to be transported through it, that we call the equilibrium, pluvial graded flow. Am I clear?
Yes, sir.
Hello?
Yes, sir.
So any pluvial system, what it always aims at? It aims at getting a graded profile. So when you are talking about the downstream part, which is actually the interaction between the subaqueous and the subaerial, the subaerial system, that is the pluvial system, it is always trying to get the graded profile. And that graded profile, it will be controlled by the base level. because the base level it is going up or it is going down, and accordingly the pluvial system it will be responding, it will come try to bring its new graded profile. So that graded profile will be actually controlling by the base level and the energy flux, that is the river discharge. Here what is the energy flux? Here energy flux is not wave or current. Here the energy flux is the sediment supply, the water discharge, the sediment supply, that is the energy flux here. And then the total sediment supply, the accommodation that it will be generating, that will be 50. Now when you come to the third case, that is the upstream not affected by the base level, then the everything remains same, only base level will not be there. There will be no control of the base level. Instead of base level, there will come the tectonics. It is the third case. Third case I am talking about. There also the main force will be the achievement of the pluvial graded profile. But there that graded profile will be not controlling by the base level, but it will control by the tectonics. Any new tectonics, you all have read the Davis geomorphological cycle, and there what they say that any new tectonics, and then there is the asymptotic fall. So any new tectonics, then the river system try to balance the new morphology and try to get its new